Okay, good morning, everyone. Thanks for joining this week's Tips and Tricks webinar. Today's topic is gateway optimization for performance. Please use the Q&A chat if you have any questions during the webinar. Make sure we get to those. Today, our presenter is our regional architect, Dan Taney. Dan, take it away.
Thank you, Rob, and good morning, everybody. Happy Friday. So I'm kind of coming back for what we'll call almost a part two from the session I did a bunch of weeks ago on policy optimization to just talk about a few things from the gateway side. So as Rob said, I'm one of the two regional architects for Mid-Atlantic and Federal. So some names here in the panel I recognize. Some I don't think I've had the pleasure of meeting, but thanks for joining today. We're going to run through real quick. So the one thing I'll just going to throw in here kind of upfront as a disclaimer. So everything I'm going to cover today came from real world examples of either things that I was involved in helping a customer with, or some of these, since I came from a customer, were things that actually happened to me in terms of, just performance on the gateway. But not all of these things are a one-size-fits-all solution. So if you see something that is interesting, that catches your eye, please take the time to kind of just review it, either with your SE or maybe or with TAC if it's troubleshooting an ongoing problem. Since not everything is just a one-size-fits-all, I'd hate to have you take away something and make a problem worse. But, like I said, these came from real world examples. So real quick, I'm just going to kind of run through. If you saw my session last time, these first two slides are going to look very familiar because they're actually exactly the same. And just real quick review what Corexl and Securexl are, because these are kind of, once again, the core foundations to the things we're going to be talking about in the next half hour. So Corexl is the checkpoint mechanism that allows our gateways to leverage multi-core CPUs. We do that by replicating a copy of the firewall kernel on each core, and we can assign these cores two different types of tasks. The SND, which is the Secure Network Distributor, or dispatcher, I'll probably call it dispatcher. They process all of the incoming traffic from the network cards in the gateway, as well as handle all of the accelerated connections that qualify for Securexl. And then the firewall worker, which will also be called Corexl instances, basically they inspect everything else. So the slow path and whatever can't be done in Securexl. So really the big one today is going to be hit a lot on the SNDs, and keeping in mind the dual role of the SND between processing incoming traffic from the network cards and then also handling the inspection of that traffic through Securexl. And so what is Securexl? That is our acceleration solution. It allows some of the more intensive CPU operations to be processed in a kind of accelerated path instead of going through the full inspection path every time. So, in our standard non-accelerated path, we have to send things up through a whole bunch of different layers in the stack, from the NIC through the acceleration device, then up into the kernel and back down. So this takes time, this takes resources, it takes CPU. Securexl allows us to identify traffic that we can just kind of fast path, fast cut, and reduce the complexity and overhead. So again, if you saw my session last time, that's just a little bit of review, and we're going to dive right into the first one. And the first topic that's been, often comes up is multi-queue. And so to kind of, before we get into what multi-queue is, let's kind of figure out like where multi-queue fits into troubleshooting and improving performance. So we may see instances on a gateway where there's very high CPU load on the S&D CPU cores. It might be all of them, but it more than likely might only be one of them. So if we're looking in top or in CP view, we're seeing, one CPU just really spiking. We've got network traffic dropping. And if we're looking, especially on the network switch side or router side, the command, I believe, would still be show buffers on a Cisco switch. You might see that we've got issues with buffers, and queues not emptying. On the gateway side, if you do netstat -ni, which I have in, oh yeah, it's okay. It's on there too, not just in the screenshot. The netstat command can show us the receive and transmit buffer drops. And so you can see here, I've kind of highlighted that in this example, there are only a few retransmit drops. This came from a VM gateway that I had, so not a ton of traffic going through it. For those of you familiar with some of Tim Hall's concepts, he gives us this really helpful equation to determine when the number of RX drops become a problem. And if we go by his formula, we divide the number of RX drops by the RX OK. So RX OK just means just literally that it was received OK. There were no issues, no drops, no errors. So if we divide that and then multiply it by 100, we get a percentage. If that percentage exceeds 0.1%, then we are likely in the territory that there is something wrong in the network configuration or something wrong on the gateway configuration, and that we're just not able to keep up. Now, I point out here the S&D cores because if you remember back on the first slide when we were talking about what the different Corexl cores do, the S&Ds have to process all the incoming NIC traffic as well as handle the Securexl flows. So if we look at the interface affinities and configuration for the CPU affinities on a gateway, that is the command in the left pane there, FWCTL affinity. This will show us the interfaces, processes, and firewall instances and how they're basically all mapped together. So let me switch to pointer view here. So we can see we've got, in this particular example, a 4-core gateway. CPU 0, if we'll notice, has ETH1 and ETH3 bound to it. CPU 2, we see, only has ETH2 bound to it. So where could this be a problem? This could be a problem what if the heaviest amounts of network traffic, for example, are coming in on ETH0 and ETH3, and maybe ETH2 actually is barely anything. Maybe it's even just a management network, or something that barely sees any traffic. If that's the scenario we're looking at, now all of a sudden we have one core that is handling the bulk of the network connections coming in through the gateway. So, this is the scenario really where multi-queue can become very important and very helpful. So if we go back to the example of seeing an S&D process spiking high on the gateway side, let's assume it's CPU 0 in this case, and we see CPU 0 is just pegged at 100%, and the other S&Ds are basically idle. And it would be a fair assumption that the cause of this could be that we have overloaded that S&D with network traffic. So this is kind of where multi-queue comes in. It can be configured for more than one network interface, and I'll show some limitations in just a minute. But basically what it lets us do is balance the load across all the S&Ds. So instead of just binding ETH0 to one CPU, it would be loaded across all the S&D instances on the gateway. So this, again, it can be configured on a per interface basis. So you don't have to do it on every interface. You may not need or want to do it on every interface. So we can look at the command. Come on. Why is my slide not advancing? MQ_MNG-show will show us kind of what our current multi-queue configuration is. And some kind of or quick requirements here. It's not supported on systems with only one core because we have to split across multiple cores. You can have a maximum of 5 interfaces on pre 3.10 kernel gateways, and we can have more than 5 on R8040 and up 3.1 kernels gateways. Anytime you change the multi-queue configuration, the gateway needs to be rebooted, and all clusters need to be configured in the same way. So this is important if you're going to turn this on or if you're going to make changes. Always remember, to hit the both active and standby gateway. So probably the most important thing to note, and this is actually in my real world kind of experience with multi-queue, where part of the bigger problem is this note here that additional SNDs may be required to balance out heavy network loads. So if we only have 2 SNDs to begin with, and they're already pretty overworked, it's multi-queue may not solve the problem by itself because we may just be spreading the load across 2 or maybe even 4 SNDs that are already highly worked. So this is where, again, multi-queue, it's a good start. It may not be the magic bullet or the silver bullet in just troubleshooting performance alone. Because what we may find when we turn on multi-queue is that we've spread the load out, but now we just have more SNDs that are overworked or just ones that are running even hotter, and there's still a little bit of a performance gap there. So that brings us to the next option is dynamic balancing. And this is really cool. This is a new feature to R8040. And in fact, it was fully implemented after Jumbo Hotfix 25. So if this sounds good to you, if this is something that sounds like might work, you want to make sure that you're at least above take 25, but always be on the current one if you can. This kind of takes our S&D balancing to the next level, and it allows us to change the balance of Corexl allocations between those firewall workers and S&Ds on the fly. So what's really awesome about this is if you don't want to mess around with all the manual balancing, or the workloads on your gateway tend to change. Maybe they change throughout the day. If you as you shift from production hours with user traffic to off hours, where maybe it's more like backups and just kind of heavier data flows overnight. There could be a lot of ways that you could get better performance from the gateway with dynamic balancing. Some people in Checkpoint have also called this dynamic split. So if you've heard the term dynamic split, we're talking about the same thing. So this is actually enabled by default on R81, which I'll just take a moment to point out if you didn't know. Earlier this week, R81 became the recommended version from Checkpoint. So if you've been kind of holding out to try it out until it was recommended, it is now recommended. And another point for dynamic balancing, multi-queue is required. So this is kind of how we're kind of layering all this on. If we've gone through the process of getting multi-queue where it should be, and then we want to go to dynamic balancing, wasn't a wasted effort because we needed multi-queue to do dynamic balancing. So basically how it works is the gateway is continuously monitoring the load of all the CPUs. And we make an estimate to determine, as we're monitoring that, if changes could be made to the Corexl allocation to improve performance. So basically the gateway is looking at, can we make a 10% or better improvement by changing the ratio of S&Ds to workers. And we kind of stick with that 10% metric to just avoid flapping and a lot of unnecessary changes. So if we just have a process spike, for a second or two, because we pushed a big connection through, we don't want things just constantly changing. So we do kind of hold to that 10% to just keep things in a steadier state. But really, that's kind of all there is to it. The dynamic balancing, like we said, it makes it simpler. Because it can do these changes on the fly without a reboot, Whereas if you were going to change your Corexl configurations manually, as you probably know, that does require a change in CP config and a restart for it to go into effect. So enough about me just kind of talking about it. Let's actually go ahead and show you here a real example of this from a lab. And so basically here we're going to show a demo in CP view of dynamic balancing in action. I believe this was ran with just a TRX traffic generator behind it. And so what we'll see here when we get started, DS status, that's dynamic split status, is on, and that we are starting out with 4 S&Ds and 28 workers. So we kick off the traffic generation, and we'll see we're still at that 4-28 split. But what starts happening is we start getting a lot of activity. And now we can see as the load on the gateway is increasing, the S&Ds are changing. And now we're at 12 and 20 and 14 and 18, 16 and 16 as, this load goes up and up. And we kind of hang there, and, this is kind of the balance we've achieved. And we've kept the gateway performance more stable. So, I mean, this is awesome. I think this is a game changer in terms of performance and performance troubleshooting because it really takes a lot of the guesswork out, and it really takes away that element of having to, maybe change these balances a number of times until you kind of find the magic number for your workflow. So that's dynamic balancing. Like I said, it's new in R8040. So if you're finding a struggle with getting the right Corexl balances, or just looking to kind of get that a little refined, dynamic balancing might be the way to go. And I think, yep. So you can look at SK164155 for the full reference for dynamic balancing or dynamic split. So the next one, and this one is one that happened to me personally when I was from my customer days. We'll call this Geopolicies Part 2, when geoblocks don't help. So this, right on the heels of the last session where I kind of was a big advocate of geopolicies and geoblocks. Let's just go with the scenario that after the last session, you went ahead, implemented geopolicy to reduce, the traffic inspected by the gateway, rule out some traffic we don't want. But ever since then, users are complaining that internet is slow. Maybe web pages are taking a long time to load. Maybe some web pages never load at all. But if they hop on a guest network that sits behind the same firewall, the same internet connection, it's fine. So what happened? If we look at our geopolicy, we've blocked Russia, China, Japan, Brazil, India. And if we look at this map below of the root hint servers for DNS around the world, we'll see in certain geo regions a large number of these root hint servers exist. Presently, as of yesterday when I looked this up, there are 12 independent server operators that are running a little over 1,400 DNS servers around the world for root hints. So root hints are often used by default, especially in Microsoft DNS, to resolve for DNS zones that don't exist local to the server. So if you're kind of using Microsoft DNS right out of the box, this may apply to you. And the problem is a lot of these root servers exist in regions where we've now geo-blocked. So we look through firewall logs and you'll actually find that there are DNS requests from your DNS servers being blocked due to geo. So the solution for this can be pretty simple. We can either put an exception in the geo policy for the DNS servers on the DNS service, just so that they do not apply to the geo rule. And so going back to our original scenario, the reason the guest Wi-Fi network turned out that it didn't have this problem was it wasn't using Microsoft DNS, and I was actually just pointing all the DNS directly to OpenDNS and foregoing the use of root hints. So it was, same gateway, same internet connection, but different policy slightly that came and bit me. So the other thing you could do, of course, is not use root hints and make just use of straight forwarders like OpenDNS or Quad9. So that was one case where being a very big advocate of geoblocks actually came back and bit me. But, to the users and at first to me, it presented like some sort of weird firewall problem. That connections were just randomly slow or timing out. And it took a little bit of digging to get down to the bottom of what the cause was. So I've got two more quick ones here. Don't want to run out of time in case there's any questions. But the next one, bad performance caused by network issues, or network interface issues. I know this slide is an absolute eye chart. My intent was not for you to be able to kind of discern everything on here, but to point out in Gaia 3.1 kernel, the ETH tool utility has been greatly enhanced. It provides much better enhanced statistics on the low-level stats of the NIC, and especially on if they're optics. So you could consider looking at this if we're going all the way back to looking at the switch interface and we're seeing high error counts, or you're observing odd cluster flapping or even intermittent loss of connectivity, and other factors have been ruled out. The issues could be with the transceivers or the interfaces themselves. And if you've ever had to troubleshoot that before on Checkpoint, it was tricky to troubleshoot. You probably needed that loopback adapter that came with the gateway that if you were like me, got buried in a drawer somewhere and, probably couldn't find to save their life when TAC told them to use it. So this command can show us a lot of stats, and that's just kind of what's on the right here about, the laser transmit power, module temperature, lots of things that could be relevant to kind of indicating that a module could be failing and that the issue you're seeing is actually a physical one and not software one. I think a lot of times we kind of skip over the physical layer because we just assume that it's been that way forever. Nothing's changed. Why would there be a physical layer problem? And we go deep on troubleshooting software and kind of miss a very early step. Very last one. And I just learned about this one actually this week. We could look at bad performance caused by flapping processes. So anyone who's been around Checkpoint for a while, you're probably familiar with CPWD admin list. The thing that I did not realize about the output of here is this number start column. That actually refers to the number of times that process has crashed and restarted. So if something seems like it's running inconsistently, if you run this command and you see that the number of start is incrementing on a service, it probably means that service is crashing and restarting, under the hood and maybe without you knowing. If you find that core files might have been saved on the gateway for when that process crashed, there's a handy file right in home admin called lastdump.log. If you cat that out, it will show you an inventory of all the core files that the gateway has captured and the path to them. So this is definitely a case where if this is happening, it could be causing performance issues. It may not be enough to make the cluster fail over, but enough that the gateway feels like it's running slow, or there's just periods of time where it just seems like everything dies and then comes back. So if you're finding that happening, this is definitely time to open a TAC case. But you can probably help yourself and help them out. Reference that there are processes crashing and upload these core files. These core files could be very useful in helping kind of determine the root cause of the problem. So I guess that's probably five things to consider when we're just looking at gateway performance. Hopefully some of these are new to you and maybe valuable and can just kind of help in your day-to-day troubleshooting of performance on the gateway. So wrapped up just about in time. Are there
No,
any questions, comments, anything
no,
I
that's
can?
great, Dan. Got a couple questions here. If you showed earlier that you could have multiple interfaces on a core, can you have
Mhm.
multiple cores for an interface if that one interface is very busy?
I'm sorry. Could you repeat that one more time, Rob? If
Yeah,
you
can you
have,
have multiple cores handling an interface?
that's what multi-queue does. So yeah, multi-queue will basically let you spread that interface out across all the cores that are designated for S&Ds.
Does that help with like elephant flows, or it doesn't break out a single connection, right?
It won't break out a single connection. So unfortunately, that won't really help with elephant flows. You know, elephant flows are still a big challenge and could probably be their own session. But the dynamic split actually could be something that might be able to help with elephant flows, because in the sense that if we had a one or multiple elephant flows eating up one of the workers, that dynamic split might be able to allocate more, either more S&Ds or more workers while that elephant flow is happening. And the dynamic dispatcher, which is something I didn't talk about, but that feature has been around, I think, since R77 and enabled by default somewhere in like maybe R8020. And I would say that probably dynamic dispatcher with the dynamic split is the best combination that I could think of that we have right now for elephant flows, because the dynamic dispatcher would let us stop assigning new connections to a core that is already very highly loaded. So, you know, instead of the kind of regular round robin way, with dispatcher on, that it would let you, or the gateway would stop sending core connections to a very busy core. So I would say if you're struggling with elephant flows, we can you could go back. There were some of the things in the last session I did on the policy side that could help get it possibly at least out of deeper inspection with the null profile. And there's another thing you could look up that I didn't talk about in either of these, which is the Securexl fast accelerator. If you just search Securexl fast accelerator on Secure Knowledge, you should be able to find the SK for it, and that basically lets you kind of hardwire source destination mappings to just pass straight through the firewall. And again, like everything, it's not without its downsides, but those are probably the best things for elephant flows.
Great. I think you covered this in CP view, but on the dynamic balancing, can you get a report on what occurred over a 24 or 48-hour period with the automatic balancing?
In terms of it changing,
Yes.
um, I would say I don't know if you could get a report. You could, if you have the CP view history turned on, which is another thing I believe we turn on by default. You could leverage, if you're looking to see what's happening with that. There is a great tool on Checkmates that somebody wrote. I don't think Checkpoint made it. It's called CP Viewer, and I think it actually, you can just download it as a VMware like OVF. And this guy wrote a tool that will let you import a CP View history file, and it actually visualizes the entire CP View database in like graphs and stats. Really helpful. So if you were looking to kind of see the history that way, something like CP Viewer might be a good way to kind of let you pull it in and see the changes visually in, you know, in the CPU consumption and all that. I would also imagine if you were monitoring the gateway with SNMP, that you could probably see, depending on the polling frequency of SNMP, see your CPUs like kind of spike up and down and them kind of like change in their utilization over time.
That's great. I didn't know about that tool out there. I'm going to check
Yeah,
that out.
it's pretty awesome. Props to whoever came up with that.
We'll send them a shirt. Uh, uh, Last one here is You talked about the DNS, the geo blocking. What's the benefit of using root hints if that is an issue or could be an issue, rather than just using your open DNS or
Yeah, personally, I don't know that there's really any value in using root hints. I mean, I'm not a DNS expert, so anybody could feel free to kind of challenge me on that. But it just seems to be one of those things that I'm not really sure what the benefit is, because there are so many DNS services now that are kind of optimizing for your your location and where your IP address resides. So I don't I really don't know why, if there's any benefit to it. I know we kind of looked at it and realized this was the problem and just said, okay, like we'll just turn this off and just use forwarders. So I'm not really sure. If anybody has a differing opinion, please, you can let me know.
Yeah, please, guys, everyone.
Yeah.
Yeah, let me know, email Dan, email me, I just love to hear your opinion on that.
Because a lot of times nowadays there are possibly even security benefits by using, a different DNS service outside of just kind of forwarding it out to the internet. So, there might be some performance benefits by using a kind of localized DNS service as well as some security ones.
Just got another question here about the DNS. What about a simple rule order for DNS accept before geo blocks?
So if you're doing geo in the policy using dynamic objects, you could definitely do that. But if you're using kind of the classic geo policy, that geo policy gets applied before the actual access policy. So this stuff would be getting dropped. In my case, at least, I was using the original geo policy. So it was getting dropped or manipulated before it even got to the access policy. But yes, if you're doing geo by the method of dynamic objects in your policy, then yeah, you could definitely put the DNS higher up. Oh yeah, okay, so you are using dynamic. Yep. So yeah, if you're doing it that way, you could just, fix your rule order and put it above those.
Great, good question. All right, Dan, I think that covers it. Thank you so much. Great information. Let's see here. I'm going to put a poll up here, a quick question for everybody. I was wondering if there was a better day for these webinars. The reason I'm asking is, as you know, we're an Israeli-based company, and on Fridays, Israel is off. So if we move it off of Fridays, I might be able to get, additional resources, people from R&D and people from Israel to present on some of these webinars. No promises, it was an idea. So I'll launch this poll. Does anybody, think there's a better day? Stick with Friday, don't care what day it's on. Just let me know and, we'll consider that. They're all recorded anyway and I send it out, but I know people like to join live. So just want to ask that. So thank you very much if you answer that. Is there anything else? Oh, I also just started a YouTube channel for the recordings. Zoom has started deleting recordings after 30 days. So any of those links that I've sent in the past are not available after 30 days. So I started populating them up on a YouTube channel so anybody can go back and watch the previous presentations. I will include a link to that page in the follow-up email also, along with any other reference content here from Dan. So I think that pretty much covers it. Our next webinar will be in 2 weeks. What is the date in 2 weeks? August 13th. So you'll see an invitation for that soon. So thank you everybody for joining. Thank you, Dan. And we'll see you back here in 2 weeks. Enjoy your weekend.
Thanks, Rob. Thanks, everybody.
Bye.